if you don't get this, I need you to tell me, because I don't want to go on unless I have you understanding where to find your z-scores. You're going to use your table 4 at the same time. I'm going to show you at the end of this how to put it in your calculator and find it in your calculator as well. Your calculator is a little bit more exact than your table is because of the rounding. So you have to find the area to the left of a z-score of 0.08. Remember your zeros in the middle. To the left is what we exactly look up. On your table, this is the, you have the ones column, and then you have the tens column. And the hundreds column is up here. Just be careful, because on the negative side, it reverses. And it starts with the 0.09, 0.08. So this would be the same as 0.10 and a 1 over here. Actually, you're only seeing this part of it, right? 0.1. Yeah, you're only seeing this part of it. This is your ones column, your tens column, your hundreds column. So if I read this piece right here, it's 0.11. See it? So if I'm looking for 0.08 and 0.0, this is what you're going to have to look up. And then up here, the 0.8. And this is the piece you're looking up. Is that okay with everybody? All right, now, don't look up the 0.8. You got to look up the 0.0 and then go to the 0.8. That's your hundreds position. Now, again, if we use the sketch, we know that area has to be greater than 50%. Half of your curve is 50%. So if you accidentally looked up the 0.8, that's 78. That would be pretty high for that little piece. You're just a little over the 50% mark. So the sketches are kind of going to help you out as well. So when you look it up, you see it's slightly bigger than the 50%. And that's what you're looking for. Your area to the left, it even shows you on your chart where they shade. It's always reading your area to the left of that z-score. Right now I want you to put the z-score of 0 in there and just put your z-score on there and shade the part that you want. So in this part, we want to the left of negative 3.16. So we shade this little piece. Doesn't that have to be a really, really small number? Now when you look in your chart, you're in the negative side, 3.1, and you're up here to the 0.06. And that's the area that you're going to take. Just be careful, the negatives go the opposite way. They start 0.09, 0.08. Okay, and look how small that area is. It's far less than 1%. It's less than 1/10 of a percent. Okay, to the right of this z-score. Now, this was a good one. Yes, but this is a thinking problem. Let's take a look at this. I wanted you to think this out. This is not in your table, right? It's not in your table. You can find negative 0.35 in your table. You can find negative 0.36 in your table. Agree? This one comes exactly in between it. So this is called extrapolating. When you extrapolate a value, given the values that you have. So halfway between those two areas, I should find my area, right? Because I want to be halfway between those two numbers. When you do this, 0.35 is 0.3632. 0.36 is 0.3594. I want a number that falls halfway between there. So I take the difference in them, I split it in half, and I just add it or subtract it. Add it to the lowest, subtract it from the higher. Probably easier to add. Add it back to your lowest number, and this is your area. But this area falls in here, to the left.
You added to the 0.0019 to the 0.3594.
To the lowest one. Or subtract it from the highest one.
Well, 0.25 not forward from the 3.6, right?
That's fine though, because don't forget these are negatives, so they work in the opposite way. So now your area is going to be halfway between here. And doesn't 0.3613 fall about, it's the halfway mark?
Yeah.
Exactly the halfway mark. You extrapolated that area. You took it out of two existing ones because you want exactly the half. For us to do a 0.3, like a 0.353, we have to take 3/10 of it. I wouldn't give you that. Exactly half. That's a nice one to do. And so then you say, okay, but that still falls to the left. And then you have to follow the rules and do the 1 minus this. And you're going to be real close because you took one of those, right? You took one of those. If you took one of those and subtracted it, you'd come real close to this, but not exactly. In last year's book, the old book, didn't have any of these where you extrapolated. When I first saw it myself, I'm like, I didn't know if you guys would round it or try the extrapolation. I don't know really if you ever had to extrapolate before off of the table. It's we don't do it as often because we used to use trig tables instead of your calculator. So if we had an angle that was halfway between two angles, we would have to extrapolate the trig values. But we don't really use tables anymore. In fact, your calculators, when they do this, are so much more exact. They can go to those extra places. We can't on our table. Your table only goes 2 decimal places. So normally you round to 2 decimals. If it's exactly half and you can find the exact halfway point, then that's doable.
You can do this on your calculator?
Yeah, I'm going to show you in a minute. Yeah, I want to go through all the sketches first. Now, to the right of 3.25, 3.25 is a very high number. This has got to be a very small area, right? Well, when you look up 3.25, look at the big number you get, and you say, could that possibly be that little area? No, but your sketch tells you subtract from 1. That's why you're sketching. So your sketch says, well, it's got to be a little piece. I need to subtract it from 1. Use your sketch to help you out. I'm real big on sketching. In fact, tomorrow we're going to develop a whole new sketch of our own that I'm going to make you use for the rest of the z-square stuff. I use a little different than the book does. Okay, we found the betweens yesterday. We said between 0 and 2.86. Well, the 0 always measures to the left. The 2.86 measures to the left. So if I take out this part where they overlap, then I'll be left with what's left over here, the one in between. So I want to find their areas, and I want to subtract their areas. Never subtract a z-score. So are all of you okay with this? Everybody was able to do that? So what's happening here for you guys that were absent, Damani and Nick, this is probably a little harder to see. It's looking at your area to the left of this, at the 0. It's looking at this whole half. Then from 2.86, it looks at all of this and all of the half that we had. Well, if we get rid of this piece, isn't that piece left? If we subtract it out. So we're getting rid of this piece. So we want to subtract our areas. We always subtract the larger area minus the smaller area because you can never have a negative area. Well, the 0 is at the 50%. The 2.86 is 50% plus a little bit more. So if we take out that 50%, we can find out what that little bit more was equal to. So yeah, we just want to find what's in between them. And it's a little more difficult for us to find in between because your area is always measured to the left. Okay, yeah, between these two in here, same way. Find your area to the left of this. Find your area to the left of this guy. See where they're overlapping? If you subtract that, you'll be left with what's in the middle. So subtract your areas. Don't subtract your z-scores.
What do you mean?
Well, when you look up in your table, the area to the left of negative 1.96.
I'm going to lie.
Because you always read your area to the left in your table. Your table always reads your area to the left.
Counts as to the right.
Okay, this is a different problem. If I ask you to the right, then you have to take your area and subtract it from 1. One of the properties of this curve is here's your standard deviations, your z-scores. We talked about the properties yesterday that the total area adds up to 1. And your z-scores have negatives and positive z-scores. The area on a specific z-score is always measured to the left. If we want the area to the right, we have to use the fact that the total area equals 1 and subtract it from 1. Okay? If we want the in-between, we have to subtract the areas. Now, the area will never be negative. Always subtract your larger area minus your smaller areas. It's kind of like, where do I overlap? I want the difference of where I overlap. Like, how's a good way to explain this? Okay, if I measure 2 pieces of wire, this piece of wire and this piece of wire, and I say, how much bigger is this piece? Don't you subtract out that area? You get rid of it, you subtract that out, and you'll find this little piece in here. Right? It's the same kind of concept. If you subtract out that area, you'll get the area that's left over. Same kind of concept. Now this one was different, and I gave you this to think this out. This is a really, really good one, and this is going to show me if you actually understand your concepts of your curve. I want the area to the left and the area to the right, and I want to add them together. Now, when you look up this area to the left, it's this. Why did I multiply this by 2? Why? Why is it the same? It is. It's the same distance from 0. Good, because your curve is symmetric. Good. So it's the same distance from 0. It's like having a number line. It's like an absolute value type thing. Very good that you saw that. But your curve is symmetric. So, yeah, no. And I wanted this area, and I want this area. Now, the concept of this being, this has to be the same amount as this. Your curve is symmetric about the mean. It's the same distance from the mean. So your curve is symmetric. So if I find the area of the negative, I should know the area to the right of that positive one. Well, if they ask you that, yes. So now, okay, so now apply that thought to this. I want the area to the right of 1.56. No, all I want is this area right here. What's the short way to do it then? No subtracting 1. Without subtracting 1, what's the short way to do it? Apply that concept right there that we just did here. This area and this area are the same.
You're not asking for the
No, all I want is this area to the right of 1.56. So if I find the negative, and what's the area for this?
What is it would be for the opposite side?
Yes. So what is it? 0.4? No, of the negative. Give me the negative. Give me the negative number.
0.0594.
Thank you. So therefore, isn't this one
Yeah.
0.0594? I didn't want to subtract the 1. You didn't have to subtract.
But if 5.6 on here does not say that.
No, it doesn't. It says 99 something because it always measures the area to the left. But now subtract that from 1. But it has to be the same thing. But the shortcut is this. If you notice that this is symmetric and the areas on the ends are exactly the same, if I use a positive number to the negative number, so I don't have to look up that positive and subtract it from 1. I could look up the negative number and not subtract it from 1. Question?
Yeah. What if you said to the right and then the
to the right, well, normally to the right, we take that number, because it measures to the left, and we subtract it from 1. But I'm showing you a little bit of a shortcut to use the fact that your curve has symmetry about the mean. It is the same distance from the mean. So the area on this side of negative 1.56 has to be equal to the area on that side.
And they're still just giving you the area of both those.
I just wanted the area, well, this is different than this problem. I just asked for the area to the right of 1.56. Okay, let's try it. Don't look at this one anymore.
I don't see one.
Okay. I know, don't look at this problem. This is a new problem.
But what, my question though, what if it's just to the right and it's negative? How do you subtract that from negative?
You can't say to the right and it's negative? Okay, I'll show you in 1 second. Okay. I want the area to the right of 2.12. Give me 2 ways to find this area. Aaron, what's the first way? The area to the right of 2.12. What's the way you would find it? Okay, so we're going to look up 2.12, and we're going to find that area to be 0.9830. And Aaron knows that can't be it, because look how little that is, right? So Aaron says he's going to subtract it from 1. Okay? Now, what's another way, Daniel, that I could do that? Go to the negative side. Daniel says this curve is symmetric. It is the same distance from 0 on the negative side. And that gives me that same exact piece as this piece is. Yeah, never need to do that. You're right.
This negative side just does a shortcut.
That's it. Absolutely right. Absolutely right. So, let's all look at this.
It's gonna help my homework.
No, I wanted you to see this. I was hoping that somebody saw this along the way, and a couple of you did. Now, when you go here, you look this up, and lo and behold, that is the same area as this one is. Now, can I have your attention for a minute? This relates back to, here's your negative 1, here's your positive 1, this was 34%, this was 34%. Wasn't it equal across the mean, about the mean? Yes, you're in parallel. See that? And I love it when you guys find it yourself. Okay, I didn't give you those 2.
Did you clap for the board?
She did. Oh, I did. Okay, now, extending your concepts a little bit. We've been talking about the area under your curve being equal to 1, and we've been talking about all the outcomes for one event of a probability being equal to 1, and I've been alluding to the fact that we can use your curve to find your probabilities. So I thought I would throw this at you. Now, how many of you actually understood this part? I saw quite a few of you do this. I saw a few of you get this. Okay, and over there, I saw a couple of you over there. Now, all this says is this. If this arrow, same thing. If this arrow says less than points to the left. So I find my z-score, and I want my area to the left. Because this is the same as your probabilities.
So whatever way the arrow points,
That's it.
That's it. And there's no like
No, nothing tricky. Why can't you just do this? I don't know.
because I didn't understand.
I don't know. Okay. This probability, we've been finding your area to the right and to the left. And I've been saying for the past couple days that your area under the curve is equal to 1, and your probabilities of all your outcomes for an event is equal to 1. So we should be able to find the probability of these things happening using your area. So all we did was flip this into a probability statement. Instead of saying find the area to the left of 1.45, a z-score, you said find the probability of a z-score being less than 1.45. It's the same area to the left. Now, Rebecca, question?
49. I only got the first one.
That's that one.
I know, but I'm talking about 49.
Okay, we'll extrapolate.
Yeah.
We're going to extrapolate that the same way we did the other one. We'll extrapolate.
So like the word problem, find area to the left of Z, if that's saying Z is less than something?
Yes. This is the equivalent of this in a probability statement. We'll get to the extrapolate.
And then you just do the same thing, like you look at the chart,
Same thing.
and you still have to graph and stuff like that?
I want sketches.
Well, you shade.
I want the sketches with the shading in it. And I do that for a couple of reasons. Tomorrow, when we start putting these to word problems, and we start combining, like say your SAT scores, where your Z scores are, where your X values are, I want the shading so that you can see which way you're going. And every year, kids say, I don't need to shade, but they give me a positive when they should give me a negative. If you shade, you'll see it. If you forgot to subtract from one, you'll see it immediately. Like when I get to something to the right of something, when I look this up, it can't be more than 50%. It's got to be a little tiny number. When I look it up, it is a large number. So it tells me subtract from one. That's what your shading does right now. I'm big on the sketches, big on the shading.
You still don't tell me about the grade, it's to the right.
To the right, to the right.
And it's the Z score is negative.
Oh, okay. So, if your z-score is negative 1.2, and you want to the right, you do the same thing. When you look this up, it is your area to the left that you look up. Okay? So you're going to look this up, and you're going to find this to be, I'll show you two ways to do this. We're going to apply it two ways. Negative 1.2. It works the same exact way. 0.1151. Now, does that look like that area is that small? It should be greater than 50%, right? So therefore, what do? Subtract it from 1. And that makes more sense. It's the same process.
On the negative side?
And it doesn't matter what side you're on. Now, we could apply what we learned before, and we could go to the 1.2, because this should be symmetric over here, and get the area to the left of the positive 1.2. And they will be the same thing as a result of this guy. So if I look up the 1.2, this will be 0.8849, which is that answer. Okay? You guys are doing good. Okay, the extrapolate one. We're extrapolating again. I look up 2.17. I look up 2.18 because 2.175 falls exactly halfway between there. So when I find my area, I want the area that's exactly halfway between us. This one's so much easier to look at. Because can you even spot the area halfway? If I'm between 50 and 54, what is half of that? 52. See it? So if I took the difference of 4, divided it in half, 2, and I added it to my smaller one, don't I get that area? Yeah. Now be careful. I want the area to the right. So I got to come over here and subtract it from 1. It can't be 98% of my curve. So I subtract it from 1.
Don't extrapolate. The answer we get
It's close. It's very close. Yes, it's close.
I don't know what you did.
Well, you don't have on your table a 2.175. You only have 2.17, you have 2.18. But I want the number that falls exactly in the middle of those. So therefore, I want the area that falls exactly. Your area is cumulative from here to here, from left to right. So shouldn't I be halfway between the 2 points? The positives are much easier to see. Shouldn't I have accumulated up to here, and then over here, up to here? I want the area that's right in the middle of that. We're going to extrapolate it. We find the two areas of surrounding the 2.175, and we take the halfway mark. Now this halfway mark what comes halfway between 9850 and 9854? There you go, you found it.
What, is that on the thing?
No, it's not on your table. We had to extrapolate that.
Oh, so basically, do you like add and divide?
Yeah, well, you would subtract the difference. There's 4 numbers between them. Divide the 4 in half, because I want the halfway, and add that 2 to the 50.
Or you could just add both.
And divide it by 2.
That's what I'm saying.
Take the average. Oh, that's fine. Oh, I'm sorry, I didn't.
You just threw me out and like.
Okay, sorry.
Atlantic Ocean.
Sorry, I didn't know you were saying take the whole thing. Yes, you can take the average of the 2. Oh, it smells blue. Nail polish. Who's polishing your nails?
Sorry.
Next, save it for later. Alright, so are we okay with this? Alright, now, we turned your probability statements. We turned your find the z-score to the middle, to the left, to the right, into a probability statement. Does this make sense now when we do it here? I want, instead of saying the area between negative, this is what we said before. This is what we said before. I want the area between that. So now, I want to find the probability, which is your area, between those two z-scores.
Do you always want to subtract it? Like,
And in between, yes, you're going to subtract your areas. Because you want to punch out the piece in the middle.
Probably that means between that. What's the one that means and?
The and, well, they'll usually ask for this piece and this piece, or this piece, or this piece. So like,
Or is the keyword for the
or in the and, yeah. The in between you're going to subtract. Like here's an or. I want to the left of this guy or to the right of this guy. I'm going to add them. Sometimes they use an and statement. Sometimes they use an or statement. Now remember, you only have to look one up because aren't the areas the exact same?
I love it.
Yes. That's your symmetry of your chart. If you don't catch the symmetry part, keep thinking about it. Because you will. All of a sudden, I'll see those light bulbs going off. You'll catch the symmetry of it. It takes a little while. Now, I'm going to show you on the calculator how this works. Let me go back to a z-score. Okay. If you have your calculator handy, pull up your calculator.
White rabbit.
My white rabbit. Now, you need to pay attention to me because this is tough. I usually have less kids that use this than not. I tend to use the table as well myself. And when you're on the 83 calculators, you have to put it in a certain order. And I'll get to that in a second. But again, go second, theirs. Now, we are doing a normal curve, not a binomial curve. This is our normal curve. Do we have a normal probability distribution function, or we have a normal cumulative distribution function? Now, aren't we accumulating our area from left to right? So we're going to come down to the normal CDF. This is not binomial. This is your normal curve. Now, oh, I don't have the software. Okay. On your calculators, okay, yes, on your calculators, it's asking for a lower limit. Hang on one second. Okay, it says this. It says lower. It says upper. It says the mean, the standard deviation, and then paste. Now, because we're on your normal standard curve, right now we're on the standard one. Your mean is 0. Your standard deviation is 1. Give me 1 minute to explain this. Now watch. This is, I want the left. So I need to know where's my lowest limit over here. Whoa, really, really low. So I'm going to make it negative 999. When the left is the lower limit, make it negative 999.
Negative point?
Yeah, no, just negative 999. Will you ever hit a negative 999? No, I don't want to ever hit it, and I'm not going to. I mean, I could even go -4, but I'm just going to go -999. Now, my upper limit is right here at the 0.08. That's the z-score I want. And come down and paste, and you will find this area. Now, on the 83 calculators, you have to do it like this. -999, 0.08, the mean, the standard deviation. So I'll put mine in. -999, no, that's fine. 0.08, that's your z-score. I need to say the mean, and I need to say the standard deviation. Oh, okay. Yeah, my thing never works.
For the right, the up would be done.
The upper would be positive 999. Yes.
You put the software on this over
Yes, I can.
So should I do that?